Now we have got parallel lines here. Which are the parallel lines? L and M are parallel lines cut by the transversal T. So as when lines are intersected by a transversal, how many angles are formed? 8 angles are formed. So I have marked all these 8 angles over here. And we have also learned what these angles are by name. Now one thing I would like to remind you, see I have marked the angles 1, 2, 3, 4, 5, 6, 7, 8 like this. It depends upon you how you mark the angles. You can even start from 1, 2, 3, 4 like this. But when you name the angles, you should be careful. Always don't say that angle 4 and angle 8 are corresponding angles. It depends upon how you mark the angles. That thing should be kept in your mind. Now when parallel lines are intersected by a transversal, there are 3 major things happening. One is the corresponding angles will be equal. Now which are the corresponding angles? Angle 4 and angle 8. Then angle 3 and angle 7. Angle 1 and angle 5. Angle 2 and angle 6. These are the corresponding angles formed when 2 lines are intersected by a transversal. Now since here we are having parallel lines, specifically we are saying. So when 2 parallel lines are intersected by a transversal, the first thing what happens is the corresponding angles are equal. So angle 4 will be equal to angle 8, angle 3 will be equal to angle 7, angle 1 equals angle 5 and angle 2 equals angle 6. Now this is given as an axiom and we say that as corresponding angles axiom. What is that axiom? When parallel lines are intersected by a transversal, the pair of corresponding angles so formed are equal. When parallel lines are intersected by a transversal, the pair of corresponding angles so formed are equal. That is corresponding angles axiom. We know what is an axiom? A statement which does not need any proof. No proof is there for that. We are taking at random that this statement is true. So conversely means on the other hand, if you go back, if 2 lines are intersected by a transversal in such a way that their corresponding angles are equal, then the lines are parallel. So here how did we go? From the last we went to the first. What is the first one? Theorem or axiom, corresponding angles axiom. If parallel lines are intersected by a transversal, the pair of corresponding angles are equal. The converse will be if 2 lines are intersected by a transversal in such a way that the pair of corresponding angles are equal, then the lines are parallel. So if I say that angle 4 is equal to angle 8, this 4 and 8 are corresponding angles. Then what does it mean? Line L will be parallel to line M. So this is corresponding angles axiom. Now the next 2 sets of angles, what are they? Alternate interior angles and co-interior angles. Those 2 we are having theorems because those statements can be proved. They can be proved with the help of earlier statements. Now we go for the alternate interior angles theorem. Now which is the alternate interior angles? Angles which are formed inside the lines and also opposite to the transversal. Now the theorem states that, alternate interior angles theorem states that when parallel lines are cut by a transversal, when 2 parallel lines are cut by a transversal, the pair of alternate interior angles are equal. They are also equal. Now here which are the alternate interior angles? That is angle 3 and angle 5, angle 2 and angle 8. So according to the theorem, the pair of alternate interior angles will be equal. So angle 3 will be equal to angle 5, angle 2 will be equal to angle 8. So what is the theorem? When two parallel lines are intersected by a transversal, the pair of alternate interior angles so formed are equal. Now what is the converse for that? Conversely, if two lines are intersected by a transversal in such a way that the pair of alternate interior angles are equal, then the lines are parallel. Is that clear? Now there is a proof for that. Now let me go for the next theorem also. Then I will give the proof for alternate interior angles. Okay. Now what is the third pair of angles formed when lines are intersected by a transversal? Co-interior angles. Now according to the theorem, it states that when parallel lines are intersected by a transversal, the pair of co-interior angles formed are supplementary. What is the meaning of supplementary? A pair of angles are said to be supplementary if their sum is 180. So here what are actually we going to say? If parallel lines are intersected by a transversal, the pair of co-interior angles are supplementary, means the sum of the co-interior angles should be equal to 180. Now which are the co-interior angles here formed? Angle 3 and angle 8, angle 2 and angle 5. So angle 3 plus angle 8 should be equal to 180 degrees, and angle 2 plus angle 5 also should be equal to 180 degrees. This is the co-interior angles theorem. That is, when parallel lines are cut by a transversal, the pair of co-interior angles are supplementary. Supplementary means the sum should be equal to 180 degrees. Now what would be its converse? If two lines are intersected by a transversal in such a way that the pair of co-interior angles are supplementary, then the lines are parallel. So is it clear? The conditions of parallel lines and transversal and vice versa. Conditions for lines to be parallel. One more time I may say, the corresponding angles axiom is, if two parallel lines are cut by a transversal, the pair of corresponding angles so formed are equal. Converse, if two lines are intersected by a transversal in such a way that the pair of corresponding angles are equal, then the lines are parallel. Then theorem on alternate angles, when two parallel lines are intersected by a transversal, then the pair of alternate interior angles so formed are equal. Converse, if two lines are intersected by a transversal in such a way that the pair of alternate interior angles are equal, then the lines are parallel. Now third one, it's also a theorem, that is, if two parallel lines are intersected by a transversal, then the pair of co-interior angles so formed are supplementary. Supplementary means the sum is 180 degrees. Converse, if two lines are intersected by a transversal in such a way that the co-interior angles are supplementary, then the lines are parallel. Now I'll give you the proof for alternate interior angles. Now we are going to prove that alternate interior angles are equal. That is, if two parallel lines are cut by a transversal, pair of alternate interior angles so formed are equal. Now which are the alternate interior angles? Angle 3 and angle 6. Here I have changed the markings. So angle 3 is equal to angle 6, angle 2 is equal to angle 5. That is what we are going to prove. That is to prove. Now what is given for us? I told you, whenever you are going to do the proof, you should be writing what is given. The figure is important. What is given? What is to be proved? Now what is given for us? L and M are two parallel lines cut by a transversal T. Now what you are asked to prove? To prove that angle 3 is equal to angle 6 and angle 2 is equal to angle 5. That is, alternate interior angles are equal. Okay, now how we are going to prove it? Now, as I told you, this is a theorem. It can be proved by taking use of some other axiom or earlier proved statements. So I am going to make use of a axiom what we have already learned. That is corresponding angles axiom. I am going to take use or make use here to prove this theorem. Now, what is this 4 and 5? 4 and 5 are corresponding angles. So by axiom, The corresponding angles are equal because it is given and lines L and M are parallel cut by the transversal T. The corresponding angle should be equal. So angle 4 is equal to angle 5. What is the reason? Corresponding angles axiom. See, you are not supposed to write the short form CAA and all. I simply wrote just for the sake of convenience. I just told you are not supposed to write like that. So corresponding angles axiom. What is that? If parallel lines are cut by transversal, the pair of corresponding angles are equal. So 4 and 5 are equal. Now, look at the line L cut by the line T. Two intersecting lines. Go for theorem. Which theorem? Vertically opposite angles theorem. When two lines are intersected, the vertically opposite angles so formed are equal. So when L and T, the line L and the line T are intersecting, which are the pair of vertically opposite angles formed? 4 and 2 are vertically opposite, 1 and 3 are also vertically opposite. Now we are concerned with this 4 and 2. So by theorem, the vertically opposite angle should be equal. So angle 4 is equal to angle 2. This is by vertically opposite angles theorem. So let us take this as equation 1 and this is equation 2. Now look at the two equations 1 and 2. Angle 4 is equal to angle 5. Angle 4 is also equal to angle 2. What does that mean? 4 is equal to 5, 4 is also equal to 2, which means 2 and 5 are also equal. The left hand side both are equal. So automatically the right hand side also should be equal. So angle 2 will be equal to angle 5. Now what are these angle 2 and angle 5? They are the alternate interior angles. So we have shown that the alternate interior angles are equal. Is that clear? The same way you can prove for the other alternate interior angle, which is at 3 and 6. There what you will take? Take these two, 1 and 6. They are corresponding angles. 1 and 3 are alternate. So 1 equals 6, 1 equals 3 also. So 3 is equal to 6. That way you can prove. It's enough that you prove for 1. So is that clear? Now converse of alternate interior angles theorem also can be proved. Converse, what is it? If two lines are intersected by transversal such that the pair of alternate interior angles are equal, then the lines are parallel. How you can show that? That means the lines are not parallel. You are going to prove that the lines are parallel. You are going to prove the converse of alternate interior angles theorem. Now what is given for us? Two lines L and M cut by a transversal T. Also the alternate interior angles are equal. That is angle 3 is equal to angle 6 and angle 5 is equal to angle 2. This is given for us. Now what you are asked to prove? To prove that L is parallel to M. You have to prove L parallel to M. Now how you are going to do it? Let us given 2 is equal to 5. Let us take that case. Or you take 3 is equal to 6. Whichever one. I am going to take 3. Okay. Angle 3 is equal to angle 6. It is given for us. 3 is equal to 6. But 3 is also equal to 1. How? How? Line L cut by the line T. Vertically opposite angles. So here we are going from back. So 3 and 6 are equal. 3 is also equal to 1. Why? Vertically opposite. This is alternate interior angles. This is vertically opposite. So angle 3 equals angle 6. It is given. Angle 3 is equal to angle 1. Reason is vertically opposite angles. So see here 3 is equal to 6. 3 is also equal to 1. What does that mean? Angle 6 is equal to angle 1. Angle 6 is equal to angle 1. Now what are these 1 and 6? Angle 1 and 6. They form a pair of corresponding angles. Both of them are placed on the same side of the transversal. Both are placed above the lines. So they form a pair of corresponding angles. So if a pair of corresponding angles are equal, corresponding angles axioms converse, what is it? Then the lines should be parallel. So hence lines L and M are parallel. Is it clear for you? The theorem is lines parallel to the same line are parallel to one another. Lines parallel to the same line are parallel to one another. So I'll give that explanation. Here we are considering three lines L, M and N cut by the transversal T. Now the theorem states that lines parallel to the same line are parallel to one another. So it is given line L is parallel to M. L is parallel to M. Also L is parallel to N. L is also parallel to N. If this is the condition, then M will be parallel to N. That is the theorem. Lines which are parallel to the same line, that is M and N are parallel to L. So M and N also will be parallel to one another. Lines which are parallel to the same line are parallel to one another. So the proof for that, now let us take the lines L, M and N cut by the transversal T. First you take the lines L and M cut by the transversal T, because it is given L is parallel to M cut by the transversal T. What about these 1 and 2, angle 1 and 2? They form a pair of corresponding angles. So they should be equal. So angle 1 is equal to angle 2. Now you take the lines L and N. Forget about the line M. Take the line L and N cut by the transversal T. What are these 1 and 3? Angles 1 and angle 3. They also form a pair of corresponding angles. So by the axiom, the corresponding angles also should be equal. So angle 1 is also equal to angle 3. So now you see, angle 1 is equal to angle 2. Angle 1 is also equal to angle 3, which means angle 2 should be equal to angle 3. Angle 2 is equal to angle 3. But what are these angle 2 and angle 3? They form a pair of corresponding angles if you consider the lines M and N cut by the transversal T. So if these corresponding angles are equal, what does it mean? By converse of corresponding angles axiom, the lines should be parallel. So M will be parallel to N. So lines parallel to the same line are parallel to one another. So hope you have understood the concepts what we have learned today. Just let us go for a quick freshening up or brushing up. We have learned about the types of angles formed when two lines are intersected by transversal. Before that we have learned what a transversal is. A transversal is a line which intersects different two or more lines at distinct points. When transversal intersects two lines, so many angles are formed. Exterior angles are there, interior angles are there, corresponding angles are there, alternate interior angles are there, co-interior angles are there. Then we have learned about the theorems and axioms related to parallel lines and transversal. Also we have learned about the conditions for lines to become parallel based on the corresponding angles, alternate interior angles and co-interior angles. And then we have also learned one more theorem, that is lines parallel to the same line are parallel to one another. So just this you need throughout your life till you stop learning geometry. This is the basic theorems for parallel lines cut by a transversal. Thank you, children.